Hi friends, I am Sujoy and today I will tell you how to convert from any base number system to any other base number system without the help of calculator. Also tell you 7 golden rules needed for those conversions. After watching this video, you will be able to convert from any base to any other base without any difficulties. So let's start. There are 4 bases: decimal, binary, octal and hexadecimal currently in use. Decimal or base 10 because it has 10 numbers of digits from 0 to 9. Binary base 2 digits 0 and 1, octal base 8 digits from 0 to 7, hexadecimal base 16 digits, 10 numbers from 0 to 9 and 6 letters from A to F. One more thing, in hexadecimal after 9 A is written as 10, B11, C12, D13, E14 and F15. Now the conversions: decimal to other number system conversion, decimal to binary conversion. This process is called repetitive division process. Here we repeatedly divide our source number by our destination base. Here destination base is binary base 2 repetitively until we get 0 at bottom, and we will write quotient at the bottom and remainder at the right. So let's start. 25 divided by 2, quotient 12, remainder 1, 12 divided by 2, quotient 6, remainder 0, 6 divided by 2, quotient 3, remainder 0, 3 divided by 2, quotient 1, remainder 1, and 1 divided by 2, quotient 0, remainder 1. This one is jumped to here and read the result upward, so it becomes 11001 in binary. For 34, pause the video and do it yourself. Next is shortcut or weighted method process. For that you have to make this table: 1 into 2, 2, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, next 32, next 64, like this. And you have to consider which numbers from this table you need to make 25. We need 16 plus 8 plus 1 to make 25. So we have taken these 3 numbers, we will write 1 below them. 1 below 16, 1 below 8 and 1 below 1, and we didn't take 4 and 2, so we will write 0 below them, so it becomes 11001. For 34 we need 32 and 2 from this, so we will write 1 below 32 and 1 below 2. Below other numbers write 0, it becomes 1001010. Isn't it easy? Decimal to octal. Again, source number 137, destination base octal or base 8. So 1000 by 8, quotient 17, remainder 1, 17 by 8, quotient 2, remainder 1, and 2 divided by 8, quotient 0, remainder 2. Read upward, 211, record octal number. Do this yourself. Decimal to hexadecimal conversion. Source number 223, destination base 16. So 2 divided by 16, quotient 13, remainder 15, 13 divided by 16, quotient 0, remainder 13. Upward, it becomes 13, 15. But we know 13 is written as D and 15 as F in hexadecimal, so it becomes DF in hexadecimal. Do it yourself. Golden rule number 1: to convert any decimal number to any other base, repeatedly divide the number by that base and write the quotient at bottom and remainder at right until we get 0 at the bottom, and read the result bottom to top, that is upward. Now the reverse conversion, back to decimal conversion, binary to decimal conversion. For that, scan the number from right to left and do this. So 1 into base to the power 0. So base, our source base is binary, so base is 2, so base to the power 0, and base power will be increasing. So 1 into 2 to the power 0, 0 into 2 to the power 1, 0 into 2 to the power 2, 1 into 2 to the power 3, and 1 into 2 to the power 4. Add up 16, 8, 0, 0, 1. It becomes 25. Do it yourself. Octal to decimal conversion. Again, same process, scan from right to left, and destination base is decimal and source base is octal. So 1 into 8 to the power 0, 1 into 8 to the power 1, 2 into 8 to the power 2. Base power increasing. Add up 1 into 8, 8, 1, 137. Do it yourself. Hexadecimal to decimal. DF. Writing in the numbers 13 and 15. Same process from right to left. 15 into 6 to the power 0, 13 into 6 to the power 1. Add up, you will get 223. Do it yourself. Golden rule number 2: to convert any number from any base to decimal number, scan the number from right to left, take the rightmost digit, multiply that by base to the power 0. Now take the digit left to it and multiply that by base to the power 1. Add the result to the previous result, keep on multiplying and adding until all digits are done. The final addition result is the equivalent decimal number. Mathematically, decimal number is D1 into b to the power 0, D2 into b to the power 1, D3 into b to the power 2, going on dn into b to the power n minus 1, where n is the number of digits in source number. Converting the fraction. Till now we did conversion using integers, yet now we will do conversions using the fraction also. So 62.625 in decimal. What is the binary equivalent? For 62, do the conversion as usual. For 0.625, I will tell you. Take the fraction part and multiply that by destination base. Here destination base is 2 or binary. So 0.625 into 2, 1.2250. Take the fraction part again multiply by 2, that is 0.500. Again take the fraction into 2, 1.000. We will stop our conversion as we get 0 after the decimal, and we will read the result downward. So it becomes 101. So for 62.625 in decimal, it becomes 11110.101 in binary. Decimal to octal fraction. So for the integer part, as usual. For fraction part, same process. Take the fraction and multiply that by destination. Here destination is octal or base 8. So 0.30 into 8, 2.40. Again fraction. 0.40 into 8, 3.20. Again take 0.20 into 8, 1.60. 0.60 into 8, 4.80. 0.80 into 8, that is 6.40. We have got our fraction 23146 downward. So for 23.30 in decimal, it becomes 35.2346 in octal. Golden rule number 3. To convert any decimal fraction to any other basis fraction, step number 1. Convert the integer part left to decimal point as usual. Step 2. Now take the fraction part, multiply it by destination base. Step 3. If the newly generated number has fraction, again take the fraction and do the same. Keep on doing step 2 and 3 until we get 0 as fraction, or we get sufficient number of fraction digits. Step 5. Read the result from top to bottom downward. Now the reverse calculation, the other basis fraction back to decimal fraction, octal fraction to decimal fraction. For integer part, same process. 5 into 8 to the power 0, 4 into 8 to the power 1. For fraction, little trick is there. 3 into 8 to the power minus 1, 5 into 8 to the power minus 2, 2 into 8 to the power minus 3. So here basis power will be negative and increasing from left to right. So it becomes 37.457 in decimal. Binary fraction to decimal fraction. Same process for integer, from left to right, from right to left. 0 into 2 to the power 0, 1 into 2 to the power 1, 0 into 2 to the power 2, 0 into 2 to the power 3, and 1 into 2 to the power 4. And for fraction, 1 into 2 to the power minus 1, 0 into the power minus 2, 1 to the power minus 3. It becomes 18.625 in decimal. Golden rule number 4. Same as rule 2 for the integer part, but for the fraction part, after the decimal point, scan the number from left to right and use the formula. D1 into b to the power minus 1, D2 into b to the power minus 2, D3 into b to the power minus 3, going on dn into b to the power minus n. That is fraction digit into base to the power minus 1 to minus n. N is the number of digits in source number. Now interconversion between the bases. I will convert from binary to octal directly without involving decimal number system. For that, scan the number from right to left and group in a group of 3. So 111, 101, 110, 001, 000. And here a single one is there, but we need 3-digit number. So we will add 2 zeros at the extreme left. So it becomes 001. And write the decimal equivalent for each group. 001 in binary, decimal 1, 000 in binary, decimal 0. Similarly 1, 110 in the binary, decimal 6, 5 and 111 in binary, decimal 7. And write the number as it is. So it becomes 101657 in octal. For the fraction, for integer, scan from right to left and group of 3. And for fraction, write the number as it is. So it becomes 67.5 in octal. Binary to hexadecimal conversion. This time same process, right to left scanning, but this time group in a group of 4. So 4 ones, 1010, 0011 and 1000. Becomes 8, 3, 10 and 15, or 8, 3, A and F in hexadecimal. For fraction conversion, scan the integer part from right to left. So it becomes 0, 111 and 11 is there. We need 2 more digits. We will write 2 zeros at the extreme left. So it becomes 0011, 0111 and For integer, for fraction part, it's 101. We need one more digit. We will write one extra 0 at the extreme right for fraction. So it becomes 11 extra 0, 1010. Becomes 37.A in hexadecimal. Golden rule number 5. To convert binary to octal, scan the integer part from right to left and group in a group by 3. Now write the below each group the corresponding decimal equivalent. For fraction part, scan from left to right and do the same. If digits are insufficient for grouping, add required numbers of zeros at the extreme left for integer part and at the extreme right for fraction part. Now you may ask, why in a group of 3 bits for octal? Because it takes maximum 3 binary bits, that is 000 for 0 and 111 for 7 in binary to represent any octal digit. For hexadecimal, the rule is to convert binary to hexadecimal, just do the same 4 steps, but this time take a group of 4 digits. Again question, why group of 4 bits for hexadecimal? Because it takes maximum 4 binary digits, 4 zeros for 0 and 4 1 for representing to represent any hexadecimal digit in binary. Golden rule number 6. Number of digits required reduces 1/3 in octal. Like 12 ones are there. If you convert in octal, it becomes 47. So that is number of digits reducing from 12 to 4. That is 1/3 in octal. Number of digits reduces 1/4 in hexadecimal. 12 ones are there. Converting into hexadecimal, it becomes 3f. So it reduces 1/4 from 12 to 3 in hexadecimal. Golden rule number 7. The larger base number system you use, the less number of digits are required to represent a number. For example, representing 65 in binary, it takes 7 digits. Binary is lowest base system, that is base 2. Converting to higher base 8, the bits are reduces to 3. Converting more higher base from 8 to 10 takes only 2 digits. This is the concept. So friends, this was my tutorial. If you like my video, please like it and subscribe to my YouTube channel. That will encourage me to upload more quality videos in future. Additionally, if you subscribe, you will be notified by an email whenever I upload a new video. You can follow my blog at www.sujoy-tech.blogspot.com. In this video, I told you how to convert manually. In next video, I will tell you how to convert using this calculator. All the conversions I will tell in this calculator. Till my next video, stay connected and thanks for watching.